In this video, you will get to create your first complete 2D game with the Godot game engine. It's called Dodge the Creeps, and in it, you dodge aliens that spawn all around the screen. This will allow us to touch on topics such as movement, how to spawn enemies randomly, how to handle the score, a bit of interface, and, well, the loose condition is if you touch a creep, it's game over, you start again. I have to give credits to Chris from KidsCanCode, who initially made this project for the official Godot documentation. He has a website I recommended early in the series and several times on the channel, Godot Recipes. It's really great. This tutorial is part of a complete free course to get started with Godot. You'll find a link on the screen in the description below to get all the previous lessons. I assume that you watched them already. Please check them out if you haven't already. We also have a complimentary free email course that will give you more insights about Godot. You can find all the details in the description below. You can unsubscribe anytime, so no strings attached. And with that, let's get started with the tutorial. Let's now get started by downloading the starter project. It contains the sprites and audio files you'll need to follow along. Link in the description below. You have to click on the .zip file here. I'm going to click on it. Download it in my downloads directory, and then I'll head to that directory to extract the archive and import the project. So I prepared a Godot project for you, but it does not contain anything other than the assets we'll need. I'm going to copy the directory and open a new instance of Godot here. Click the import button, paste the path to the project, and click import and edit to open it in the engine. We'll first create and then code our player. We wanted to interact with the monsters as we saw. To do so, we're going to create a new scene with an Area 2D node at the root. So you want to click Other Node and look for Area 2D. It's a node that can detect something within an area, like your character touching another. We're going to rename the node to Player, and we're going to add two things as a child of it. We have several sprites in the out folder for the player. We have 4, and they're here to make really little animations. We can create animated sprites. There's a node with the same name, which we're going to create now. So you can press Ctrl A to create a new node as a child of the selected one and look for animated sprite. To set up the animations in the inspector, we have to set the frames to a new sprite frames. You click on empty and create new sprite frames. And when you click on the sprite frames, a new editor appears in the bottom panel. On the left, you have the animations, and we're going to have 2, the character looking to the right and looking up. So you can click on default and you can rename that to right. And we want to go in the file system tab in the art directory and select the 2 player walk frames. I'm going to click and drag them over the second area, the animation frames, to create the animation. The animation will run at a speed of 5 frames per second, FPS, and will loop automatically. And you can see the character appears here as well. Now we're going to create a new animation by clicking the new animation icon in the left and click it to rename it to up. For this one, we want to select the 2 player up sprites and drag them into our animation frames. Now we can head back to the inspector on the right to set the default animation with the animation drop down here. And you can set it to right to have the character look right by default. With that, we can click away from the character to hide the interface. And you'll see in our scene, we have a little warning sign. So when a node is lacking configuration, this will appear and you can click the message to see the problem. Area 2D needs a component as a child, a collision shape or a collision polygon. It's a shape that gives the mathematical geometric form of your character for the physics engine. We're going to select the player and press Ctrl A to add a new collision shape 2D node. So be sure to select Collision Shape 2D and not Collision Polygon 2D. Collision Shape 2D then needs a shape. On the right in the inspector, you can click on Shape and create one of these geometric shapes. We're going to create a capsule here, Capsule Shape 2D. It appears in the view and you have 2 handles that you can click to change the capsule's shape. So you can click the top gizmo to make it longer and the right one to set the radius of the capsule. With that, we have our scene set up, so we're going to get coding. But first, we have to save it. So press Ctrl S and save the file as player.tscn. Now we have saved the scene, we can attach a script to the player node. Select the node, click the Attach Script button, and we're going to start with the empty template this time around. You can click Create. All right, so we're first going to code the character's movement. And to do so, we'll instantly define a speed property by typing var speed. I'll set it to 400 pixels per second. This will dictate the player's movement speed. Now, one thing we can do is make it editable in the editor, in the inspector, directly on our player. To do so, we use the export keyword before a property, so around the top of your script. When you save, you can go back to the player node, and the speed is now editable in the inspector. Note that when you change that value, it's going to override what you have written in the script. It's going to take over it, and you can click the icon to reset the value to that of the script. Okay, so back to the script, I'll click on it. We're going to start calculating our player's direction. To do so, we define the process function, which is where we define how the character updates every frame. And we're going to create a new variable named direction. This is going to be the player's input direction. And we're going to set it to vector2.0 by default. And if you remember, this is equivalent to a vector with coordinates 0, 0. Now, we want to check for the player's input, and we can do so by doing if input.isActionPressed, like this, and use one of the predefined actions, but they are not defined for example, moving with the WASD keys. We're going to have to create new actions instead, which we can do by going to Project, Project Settings, and the Input Map tab. There, you have the predefined actions that come with your Godot project, and we can create new ones by entering their name in the action field at the top. So we're going to call them move underscore, and we're going to create move right. You can press enter to create the action. It appears here at the bottom. We're going to do move left, move up, and move down. Now for each of them, we can click the plus icon next to it and select what kind of key press or input we want to map to that action. Key stands for the keyboard keys, and we can use that to then type the key. In that little pop-up, it tells you what key is going to be added to the action. So for move right, it's going to be D. For move left, I'm going to add the A key, move up the W key, and move down the S key. You can add more, you could add the arrow keys, and you could also add for each of them a joy axis if you want to use a gamepad, an Xbox, PlayStation, or Nintendo controller, something like that. But I'm going to stick to that so we can move forward. All right, so now we can use these actions directly in our script. We can write if input.isActionPressed, and we have our new move actions at the top. So if we press move right, we're going to set direction.x. We're going to add 1 to it. Why do we add 1? Well, because we're going to do something similar for move left. And to do so, we're going to select our 2 lines and press Ctrl D to duplicate them. Be sure to make the indentation level match for the if keywords and the instruction inside. So we can change move right to move left, and then for the direction, we're going to set it to -=1. So if you press left and right, it's going to add 1, remove 1, you're going to be left with 0, the character will not move. It's one way to implement or to code direction where opposing keys are going to cancel out. We can do something similar for up and down. So to do so, we can select, you need to select up to the line before and press Ctrl D to duplicate the selection. And now we're going to change these instructions to check if we pressed move down to start with. In that case, we're going to set direction.y. We're going to add 1 to it because the y-axis points down in games. And we're going to change the last one to move up, in which case we're going to subtract 1 to the y direction. Be really careful that you set them right, that you change the x direction when pressing move right or move left, and that you change the y direction when pressing move down and up. So now this gives us a direction vector, which can have +1, -1 on both the x and y axes. This is not enough to calculate a direction, because if you are pressing right and up or down, you're going to have a vector of length greater than 1. This happens in some games where when you press 2 keys, you move faster going diagonally than going just up and down. In most games, you don't want that to happen. It's almost like a bug. So we're going to check if the length of the direction vector is greater than 1. We can type direction.length. It's a method of the vector. And if it's greater than 1, then we're going to change the direction vector. There's a function to make it a length of 1 in any case, which is the normalized method. So you can type direction equals direction.normalized. So if the player presses 2 keys at the same time and makes the vector too long, we normalize it to ensure that the player moves at a constant speed regardless of the direction. Now we can use that to move the character. So we're going to add to the position the product of direction times speed times delta. And this is how you would typically move an area node. Note this is not the only way to code a character, and we'll see how to use kinematic bodies in 3D in the next video. But for now, you can press F6 to test your player, and you can move it with the WASD keys. Okay, be sure to press F6 or to click this icon up there to play the current scene. Right now, there's a nasty thing that happens when we move the character away from the screen. It can move away and away and away, and we don't want that to happen. We want to keep the player within the screen at all times. To do so, we can get the size of this game window here and limit the player's position to it. So we're going to add a new property at the top of the script. We're going to call it screen size. We could set it to vector2.0, I guess. Then in the ready function, so when the character gets added to the game world, we're going to get the screen size from the engine. And to do so, there's a function called getViewportRect. It gives you the viewport rectangle. And this viewport rectangle has a size property, which is a vector2 that gives you the size of the game viewport. If you want to see it when we play the game, you can print the value with the print function, press F6, and you're going to see here the default size of our game is 1024 × 600. We can now use that in the process function. We're going to go back down and we're going to limit the player's position. So there we can say position.x is going to be equal to, there's a function called clamp, which is going to limit a value between 2 other values. So we can clamp the position.x between 0, which is the left edge of the screen, the start of the game world, and screen size.x. Then we can do something similar for position.y. It's going to be clamp position.y between 0 and the screen size.y. If you play the game now, you can try to move the character and it won't go outside the screen. It's going to be limited. So you can see it's the center point of the character. To be exact, if you go back to the character scene, it's this point, this little cross you see in the center, that's going to be limited. That won't be able to go out of the screen. But that's better than being able to go far away. Now we're going to work on animations. We set up our animated sprite, so it would be nice to do something with it. We're going to first play and stop the animation based on the character's direction. So here, when we're checking for the length of the direction vector, if the length is greater than 1, it means the player is pressing 2 keys at the same time. We could change this to if direction.length is greater than 0, it means that the player is pressing at least 1 movement key. In which case, we can normalize the vector, it won't do anything bad, and we can do something else. We can play our animated sprites animation. So first we need to get the animated sprite node, let's say child of our player here, and it has a method called play to play its current animation. We don't have to pass any argument, we'll play the current animation. I want to change this bit here because we can write the getNode function to get a node, but there's a shorthand for it. It's the $sign in GDScript, and you can see it appears in green. And this gives you the ability to get the animated sprite node. It's just a shorthand for the getNode function. We use it a lot in GDScript just because otherwise you'll get to write the getNode function a ton. This is a bit more readable. Okay, so if we have a movement direction, we play the animation. Now we can add an else clause to our condition. We have to align the else keyword with the if one. If we don't have a movement direction, then we're going to get the animated sprite node and call the stop method on it, which will stop the animation. You can press F6 to test the game, and if you move, the character is going to animate, but when you release the key, the animation stops. Now, we're not using our two animations. Remember that we had the up and right animations. So to play those, we're going to add some code at the bottom of our process function. We can make it so if there's a horizontal direction, we play the right animation. Otherwise, if there's a vertical direction, we're going to play the up animation. So let's do it like this. If direction.x is not equal to 0, it means the player is pressing left or right. In that case, we get the animated sprite and we set its animation, it's a property of the animated sprite, to, we're going to type right in quotes. We type the exact name of the animation. Then we have another keyword for conditions that is elif. It's the contraction of else and if, and it means if this is false, but the following condition we're going to write is true, we're going to run my block of code. You can say elif direction.y is not equal to 0. If there's a vertical input, we're going to set the animation to up. Okay, so that's one more step. We can play the game and see that when we press up or down, the character looks up, and if we press left or right, the character looks right. Now it would be cool if the character, when we press down, would look down, and we can do that. So our sprite has some properties. If I go back to the scene and select the animated sprite, you can flip it using the flip H and V properties. So if I click flip H, it's going to look left. If I click flip V, it's going to flip vertically. So going back to the script, we can access the properties. It's the same name, but with underscores. And if you hover a property, you're going to see the name in the code. In this case, flip_H. So back to the script, we're going to update our conditions here. If the X direction is not 0, we can set the animated sprites flip H to, and so we can use a Boolean expression here. Remember, I told you that these expressions we put after the if evaluate to true or false. Flip H is like a switch, so it takes a Boolean value, either true or false. And so we can use one of these expressions that will turn into true or false based on the expression that we write. And we can say, we're going to flip the character if the X direction is lower than 0. If it's equal to -1, that is to say, if the player is pressing the A key to go left. We also want to do one thing. If the character is moving horizontally, we want to ensure that flip V is turned off, so the character is not looking down. So we're going to type animated sprite.flipV is equals to false here. Note that the order of these lines here really doesn't matter. And finally, if the character is moving down, up or down, we're going to do something similar to this line. We're going to take the animated sprite and set flip V, flip vertical. We want to flip vertically if the character is moving down. That is, if direction.y is greater than 0. when the player is pressing the S key moving down. And if you do that, you can now play the game, and you're going to see if you move up or down, the character is going to look up or down. If you move left or right, the character is going to look in the direction it's moving. And so with that, we have the character's animation. And that does it for now for our player. We'll add some more code later when we put the game together, but we have a moving character. What do we do next? We need to do the monster. We will now create the enemy base scene. We're going to make a template that we can then generate all around the screen with code. We create a new scene by going to Scene, New Scene, and we'll create another kind of node, a rigid body 2D. We'll rename it mob, as in MMORPGs and some games. The rigid body, just to explain, is one of the 3 body types in Godot. There's one called kinematic body, one called static, and rigid body. Basically, the rigid body, you can move it with physics forces, and its movement relies a lot on the physics engine. The bouncing balls we had a few lessons ago were rigid bodies, and here it's going to make our code fairly simple. So we want our monster to have an animated sprite. So select it, press Ctrl A, and add an animated sprite node as a child. Select the mob again, because we're going to add a collision shape 2D, like we did for the area. The physics bodies all need a collision shape or collision polygon to work. And later we'll add another node, but we're going to set up those 2 already. So select the animated sprite node, and once again we're going to create new sprite frames and click to open the animation editor. We're going to use the animations to generate enemies with different looks. The first one is a flying enemy, so I rename the default animation to fly. And in the art directory, you will see enemy flying 1 and 2, so you can drag those. We're going to create a new animation, this time for the swimming enemy. You have 2 enemy swimming frames, so you click and drag them here. And the last one is, we'll call it walking, so walk. And you can select and drag the enemy walking sprites in there. We will use code to select one of these animations at random when we spawn a new enemy. You can now fold the sprite frames editor, and we're going to set the collision shape 2D. Once again, we want to add a capsule shape 2D to it, and we're going to rotate it by 90 degrees. So you have a rotate tool here. You can press the E key to activate it, and you can click and maintain the Control key down to snap the rotation to 15-degree increments until you rotate it 90 degrees. And then you can resize the capsule to match the enemy using the 2 handles. So when the player touches that area, it will die. Now we'll do one thing, introduce a new feature called groups. It's a tagging system in Godot. So select the mob node, and next to the inspector in the node tab, in the group subtab, we can add a tag to this node. It's just a keyword that we can then check for in our code to find monsters, to detect them, or to call a function on all of them. So we're going to add a new group named mobs. You can press enter to add it, and our scene setup is done. We can get coding now. So we're going to press Ctrl S to save the mob scene. Then we attach a new script to it, and you can leave the default. It should have the empty template and save to mob.gd. Click create. We're going to define some properties on our monsters that will not use directly in this script, but the code that will spawn enemies randomly is going to use these properties. We're going to have 2, and we'll export them so we can edit them in the inspector. One is going to be the minimum speed, and I'll expand the code editor. The minimum speed, let's say 150 pixels per second. We can now duplicate the line and call the next one max speed, which will be 250 pixels per second. Here, we'll write some code to change the monster's look randomly. We'll use the ready function to do that, which will run whenever a monster is added to the game scene. And there, we'll set the animated sprite to play. So we can say animated sprite.play, or we could do, there's also a playing property that does the same thing, playing equals true. Now we want to randomly set a monster here, and what we can do for that is we're going to define a new variable, mob types, and it's going to be a list of our animation names in the animated sprite here. So we have fly, swim, and walk, but we don't want to hard code it. We'd rather get them so later you can add more monsters, you design more, you add more animations, and everything just works. To do so, we're going to use a function of our sprite frames. We get the animated sprite node dot frames, and if we go to the animated sprite, this is the first property that we set here. This is an object called a resource, which has a method that can give us the list of animation names. So we write a dot get animation names. There we go. So this is a list, an array of our animation names. It's going to look like we're going to have fly, walk, etc. And so we can assign one of these at random to our currently playing animation. So we're going to get the animated sprite dot animation. This is the currently playing animation is equal to, we're going to access mob types, and we add square brackets, which allows you to index the list. So you could say 0 to get the first animation, 1 to get the second, 2 to get the third. Now, of course, if you add or remove animations, the maximum number then will be different. So we want to write code to dynamically select a random number based on the number of animations. And here's how we can do it. We call a function called randi. It generates a random number, which can be very, very large. And so one way to get a number that is within the available mob types is to use the modulo sign, the percentage key on your keyboard, which returns the remainder of a division by the number we're going to write. And that number is going to be mobtypes.size. This method on the mob types array returns the number of elements in the array. And a modulo is going to, at most, give you this number minus 1, which is the maximum index of our array, because array starts at index 0. So if we have 3 mob types, we can pass number 0, 1, or 2 in the square brackets, and this expression here will do that for us. I'll move the monster temporarily to the center of my scene so we can see how it's working right now. If we press F6, you can see it's falling automatically. This is due to that rigid body, which has some gravity applied to it by default. To remove the gravity, we set the gravity scale property down to 0. Then if you press F6, you're going to see every time it's the same monster. So it looks like our code's not working, but actually it is. It's just that when you use random numbers in a computer, the numbers are not exactly random. They're just calculated by the computer to appear to be random. To randomize the character, we're going to add a temporary line just for testing called randomize. It will randomize the base number the computer uses to generate pseudo-random numbers. And now if you press F6, every time you're going to see a different character. So sometimes you'll have the same twice in a row, but you can see they change. Okay, be sure to remove that line. It was just for testing. And we're going to do one last thing while we're here. So I'll place my character back to the top left by setting its transform position back to 0. I reset the property in the inspector. And then I'm going to add one more node to the mob. It's called visibility notifier 2D. This node tells you when your monster entered or left the screen. And we're going to use that to delete the monster, to destroy the object when it leaves the screen. First, you can see, it's a bit hard to see, but you have a pink rectangle that appears. This is what the engine uses to detect entering or leaving the screen. And it's a bit small by default, so we want to make it a bit larger. To do this, we're going to set the X to -50, the Y to -30, -40, let's say. And we're going to set the width and height to 180. So when this entire box is going to be outside the screen, we'll use that to delete the character. You can unhide the collision shape. And so the visibility notifier gives you signals to do this. So with the node selected, we go to the Node tab, to the Signals subtab, and we're going to connect the screen exited signal by double-clicking on it to our mob. We click Connect, which creates a new function. And when the monster exited the screen, when we get this signal, we're going to call a function called queueFree. This is a function that will free the monster from memory, from the game, destroying it essentially. It's called queueFree for technical reasons. There's another function called free, which instantly destroys the monster. queueFree is safer and lets the engine handle removing the monster at the end of a frame. But with that, we have our monster ready to spawn, and that's what we'll do next, setting up our game scene. So we'll create a new scene where we'll set up our main game. As the root, we want to add a regular node here, which we'll call main, and save the scene as main.tscn. We're going to start by adding some background to it. I'll zoom out and add a color rectangle node. We'll use the layout menu for rectangle to make the color rectangle span the entire viewport. Then we can set its color to a dark gray teal. Here I prepared the color that we use in the final demo. Now the game is currently in landscape view. We want to change it to be a bit more vertical. To do so, we're going to go to Project, Project Settings, and you want to scroll down on the left until you reach Display Window. Then you can change your game's base resolution. We're going to change the width to 480 and the height to 720. It's important to change it now because it will affect where we place elements on the screen. We'll scroll down a bit as well, down to the stretch category. This controls how the game window renders as you change its size. There's a mode named 2D, which makes it so as you make the window bigger, the rendering is also of a higher resolution. That's as opposed to viewport, which is going to always maintain your width and height, stretching the pixels onto the game window, which you use typically in 3D games. But here we're going to work with 2D. And for the aspect ratio, we're going to set it to keep. Here's how it looks. We're going to have a rectangle fill the entire viewport. Now if you try to expand the game, you get black bands. There's another mode called expand, which will render more of the game. It depends on the kind of game you are making. Next up, we're going to create a path to randomly spawn monsters all around the screen. There's a node in Godot to do so. It's called Path2D. So select the main node and Control A to add a Path2D node. Here, we can use the icons at the top to create new points. We're also going to turn on the grid with the grid icon. So this is grid snapping, and the one next to it is the grid. And by default, it's a bit small. So we can click the three dots next to it to configure snapping and configure the grid. For the grid steps, we can use a value that divides 720 and 480, our game's dimensions. 40 pixels is a good one. You can press Enter and click OK to see the grid change. Now we're going to click the green plus icon, the one to add points at the top, and then click in the top left corner, click in the top right corner, and fill the path clockwise like so. And when you reach the bottom left corner, there is an icon to close the curve. So you can click it and it will complete the path. If you go back to the leftmost tool, this one allows you to select existing points. And you can see that you have two vertices in the top left corner. Now it's important to create the points in this order because the orientation of the monsters will depend on the order in which you created the path. We're going to rename this to mob path. This is the path along which we'll generate the mobs. And we're going to add another node as a child of it, which allows us to randomly generate a point along that path. So select mob path and add a pathFollow2D node to it. This one, it might be a bit hard to see in the video, but you can see the cursor here, the position, and the properties in the inspector. If I increase the unit offset, the cursor moves along the path. And so we can easily generate a value between 0 and 1 to get a random position around the screen. we'll call this node mob spawn location. To visualize that a bit better, actually, we can add a temporary mob as a child of it, and we can increase the unit offset so you can see how it moves along the path. Then you can delete the node. We need one more node to spawn our monsters, a timer. So we're going to select main and add a timer node as a child of it. We're going to set it to auto start and to a duration of 0.5 seconds. This timer will cycle, emitting its timeout signal. Every time it times out, we will spawn a new monster. So we'll call this timer mob timer. So save your scene and we can get coding now. You can attach a new script to main. And right away, we're going to connect the mob timer's timeout signal to the main node. So select mob timer, go to the node tab, and double click the timeout signal. Connect it to main, and this is where we'll spawn the monsters. First of all, we need a scene to instantiate via code. So we're going to create an exported variable. We'll call it mob scene. This gives us an error because when you export a variable, Godot needs to know the type of it to give you the proper field here in the editor, whether it's a text, drop down, those kinds of things. We can give a hint of what we want to put in that mob scene by adding parentheses, and we're going to use the packed scene type. This is the type for your .tscn files. Once you do that, when you select the main node, the mob scene field appears in the inspector. There, you can click and drag mob.tscn from your file system onto the property. With that, we can focus on spawning monsters. We're going to do a few things. First, we're going to get a random location to spawn the monster. Then we'll create an instance of the monster and place it at that location. And finally, we'll set its velocity to move towards the player or towards the other side of the screen. Let's start by getting the location. So we'll get the mob spawn location node. We're going to store the reference in a variable, and we can use the $sign to get it here, mob spawn location. We can get a random position along the curve by setting its unit offset property. So let's set mob spawn location dot unit offset to, we're going to call the randf function. This generates a random decimal value between 0 and 1. To place the mob there, we need to create a new one. So we're going to create a new variable named mob, and we're going to instantiate the mob scene from code. So we call mobScene.instance to do that. Then, like that, the mob does not exist in the scene tree yet, so we need to add it. There's an addChild method to do so. So we're going to add the mob as a child of the main node. Then we can assign the position we got to the mob. So we're going to get mob spawn location dot position. When you change the unit offset, it updates the position of the pathFollow node, and so you can use it to assign it to our mob. Then we're going to set the monster's direction. We're going to rotate it to look in a certain direction and to move in that direction. We can also get that rotation from the mob spawn location. So we do mob spawn location dot rotation. Plus, you saw that when we added the monster to the spawn location here, it was aligned with it. And as we moved along the path, the monster stays aligned with it. So now, going back to the code, we want to turn the monster by 90 degrees. And that's where the order in which you created the point matters. If we add pi out of 2, it's going to turn 90 degrees. Then we're going to add a random angle to that direction. So we're going to use another function which generates a random number called random range. We're going to generate a value between minus pi divided by 4, so minus 45 degrees, and plus pi divided by 4, which will offset the direction randomly. Finally, we'll use that as the mob's rotation. So mob rotation equals direction. These 4 lines will randomize the monster's position and direction, but it won't move just yet. To move it, we're going to calculate a velocity. That velocity is going to be a vector 2, and we're only going to set the x-axis. There we're also going to randomize the velocity. So we'll use rand range again. We're going to randomize it between mob.min speed, the minimum speed, and mob.max speed. And on the y-axis, we'll use a value of 0. So we have a vector pointing to the right. Now we're going to use the rotated method on that vector to rotate it. And we can assign the result to the mob's linear velocity. This is a property of rigid body 2D, which will make the monster move. We're going to assign it velocity.rotated by the direction, which is really a random angle. With that, you can already play the scene and you should see monsters spawn randomly going in various directions. There is one more thing that we can add here in the ready function. At the start of the game, we're going to call the randomize function, just so that the numbers that we generate are different every game. This will make the monsters spawn differently every game. There's one little thing that I forgot. If we play a bit, you'll see the monsters start to hit each other and get blocked. We have to fix that. So that has to do with the mob's properties. We'll head back to the mob scene right now, select the mob, and in the inspector, we're going to go down to collisions and we're going to remove the layer and mask. This is causing the monsters to detect each other and to hit each other. And once we've done that, we're going to go back to main, play the scene, and the monsters should now go through each other. We'll now complete the gameplay by adding an instance of our player to the scene. Click and drag the player.tscn file onto the main node to instantiate it. Then we're going to move it to the center, and to do so you press W and click and drag. W is the move tool up there. If you play the scene with F6, you can't collide with the enemies right now, so we need to fix that. We need to add some code. I also noticed that I made a little mistake in the mob scene, so we're going to open it, double click on it. And I told you to turn off the layer and the mask, the collision layer and mask, but we need the layer to be on for the player node to detect collisions with the monster. You can then close the mob scene. That's not enough though. We also need to go back to the player scene, and the area can detect monsters that touch it, that enter it, but we need to set this up. So select the player node and go to the node tab, signals, and area provides you with signals like area entered and body entered. The body entered signal detects any physics body like the monster's rigid body 2D, and area entered will detect other areas overlapping with this one. So want to connect body entered, we double click on it, to the player node. It's going to add that function at the bottom. Now we're going to make some changes to the code. So first, when an enemy touches the player, we're going to hide the node. There is a function to turn the visibility of the node off. Then we're going to deactivate its collision shape so collisions aren't detected anymore. So to do so, we get access to the collision shape 2D node, and we're going to do something a bit special. So if we select the collision shape in the inspector, you can see it has a disabled property. You can turn it on to disable the collider. Then nothing will be detected anymore. Now there's a little particularity of physics engine, which are that you can't make some changes instantly in the code sometimes. So we have to call a method called setDeferred, and we're going to pass the property name as a string as the first argument. It's going to be the disabled property, and we're going to set the property to true. This is similar to saying collision shape 2D dot disabled equals true, except that setDeferred will automatically wait for the end of the physics calculation, the physics frame, before changing the property, allowing you to change it safely and make the change work. We're also going to define a signal here that we'll use later. So we're going to scroll to the top of the script and define a signal named hit to know when the player was hit by something. Then we go back down and we're going to emit that signal when the character got hit by an enemy. So we call the emit signal method we saw in the previous video, and we're going to emit the hit signal. We'll define one last function as well here. We're going to call it start, and we'll have the game code call it at the start of the game, it will initialize the player if you want. The start function will take a new position, and we're going to set the character's position to that new position. It will be passed by the game. It will reset the player's position. When we start the game, we'll also show the player, which allows us to hide the player when it dies. Then when you click play again, you're going to show the player again. And then we have to set collision shape 2D dot disabled equals false. We need to use set deferred to turn on the disable property, but we won't have to do that when restarting the game because we won't have any physics interaction happening. Here, when the character gets hit and that function gets called, the physics engine is in the middle of calculating interactions. This is why we have to call this method. And that should be enough to test our gameplay. So you can press F5. We're going to set the main scene as our main scene to play. When we press F5, click open. And let's see, if I touch an enemy, I disappear. So the gameplay is working. Now we need to add some interface and to make the monsters stop spawning when we got hit so we can restart the game. We're going to do a bit of interface design now. So let's go back to the main scene. Actually, we're going to create a new one. We're going to go to scene, new scene. And the top of the scene is going to be a special node called a canvas layer. Create another node and type canvas layer to create it. We're going to name it HUD for heads up display. This scene will contain our interface. We're going to create labels like we did before in the series. So let's add a new label node. We're going to add 2 of them. So we're going to select the label and press Ctrl D to duplicate it. The first label is going to be for our score. So we're going to call it score label. The second one is going to be message label. It's going to be a message that will display in the center of the screen. So select the score label. The score we're going to display around the top. So we'll go to layout and we're going to have center top here. We'll center the label at the top. Message label, we're going to center on the screen. So select the node and go to layout, center. We're going to write the game's name in there, dodge the creeps, and we'll also use code to update the text. And we'll set a nicer font with a bigger text size in a second. For the score label, we're going to set the score to 0 by default, and we are lacking a button. So select the HUD node and add a new button node. And the button, we're also going to center on the screen. So you go to layout center, and then you want to move it down a bit. These options, the layout options, anchor the node, for example, in that case, relative to the center. So we're offsetting it from the center. And with the button selected, we're going to set the text to start. Now, of course, everything looks way too small. The text is pretty ugly. So we're going to add a different text font before configuring the nodes to align them a bit more nicely. In the file system doc, you have a fonts directory with a text font that we included in the project. We're going to assign it to all our objects here. Select the score label, and we're going to scroll down to where we have custom fonts here. I'll just mention that the method we're going to use is fine when you just have a bit of text in your game. So you can use the custom font property to set it on 2 or 3 nodes. In larger games, you might want to use the theme property, which allows you to apply the same font and the same UI styles to many nodes at once. Anyway, expand custom fonts and click the empty here to create a new dynamic font resource in it. Dynamic font is one you create from these TTF or OTF vector font files. Okay, so I'm going to create the dynamic font and click to expand it. First, we need to set the font. It's going to take one of these files, so click and drag xoleniumregular.ttf onto the font data, and you'll see the 0 up there changes. It's still a bit small though, so I want to expand the settings this time to change the size to something like 60, let's say. Seems big enough. Now we want to copy that font onto the other 2 nodes. To do so, right-click the resource. You're going to click copy, and then select the other two nodes, and you want to expand custom fonts, right click and paste. When you select multiple nodes, you can edit them all at once, and the inspector will show you all the properties that they have in common. That's why some of the properties disappear as well. Now we want to configure our nodes to stay centered on the screen. So we're going to select the score here, and we're going to resize the box a bit to give it maximum space. It's going to take all the width of the display. In its properties, we want to set align to center the text inside that box. That's all we need to do. We do it so when we add more characters, the text doesn't expand to the right, but stays centered. And to do so, we want the text box to span the entire width of the screen. Then we have dodge the creeps here. We want to do the same, so align center. We're going to turn on auto wrap as well, so the text wraps in the text box. Then you want to expand the box horizontally, and you can Control Alt click and drag on the handles to do so, and you want it to take the entire width here. For the button, we're going to go to layout center again to recenter it and move it down. You can Control Shift click and drag to constrain the button when moving it down. And then you can select the nodes and you can move them back up. Perhaps I want you a bit more down like that. There we go. That will be our interface. With that, we can save the scene to hud.tscn and get coding. Select the HUD node and attach a new script to it. In this script, we're going to define a few functions that we can call from the main game to display a message to update the score. We're going to start with a signal called start game. We'll emit it when the player presses the start button. And we can actually do this right now. Select the button here. And in the node tab, we'll connect the press signal to the HUD. When that happens, we want to hide the button. So we'll call button.hide, and we'll emit the start game signal. Then we'll add two more functions above that. One to update the score. So let's call it update score. It's going to update the number displayed on the score label. So for that, we'll pass in an argument, a number called score, and we'll get the score label and set its text property. We have the score value, which is a number, and we need to convert it to text using the str, which stands for string function, and passing in the score here. That way, the main node, which is going to keep track of the current score, will be able to update it in the interface. You often have that separation in games. The next function we'll do is show message, and it's going to display some text in the message label, because we'll want to not only display the title, but game over and a message to tell the player to get ready to start. So this one is going to get the message label, and we're going to set its text to the text here. We're also going to show it, because during gameplay we'll hide it. So we're going to call its show function. And finally, one thing we want to do is when we display a message like game over or get ready, we only want to display it for a few moments. To do so, we'll use a timer. So select the HUD node, and going back to the scene, add a new timer node as a child of it. We'll call it message timer. We'll connect its timeout signal to the HUD. And we're going to select the node. In the inspector, we'll set its wait time to something like 2 seconds. We don't want it to automatically start. We'll control the timer from code, and we want to turn on one shot. Before, we saw that timers cycle continuously. With the one shot property, they will play only once until they emit the timeout signal. Then they won't do anything until you call their start method again. From there, we go back to the script. And in the show message function, we're going to start the timer. So we get the message timer, and we're going to call start on it. This is a function to start the timer. Then in the onMessageTimer timeout function, we're going to hide the message label. So we'll get the message label and call the hide method on it. So when we call showMessage, we show the label for some seconds until the timer times out, where we hide the message. We're going to use that function right away by adding a function to display the game over message. So we'll write a new function called showGameOver. That way the main node, the main script can call it and handle the flow of the game. And we'll call showMessage init and show the game over message. And I guess we'll stop there for now. We'll add some more code later, but let's bounce back to the main game scene to add our HUD and to start displaying the score and everything. So click and drag HUD as a child of the main here, and we'll start counting and updating the score. We are now going to count the score and update the score label. To do so, we're going to use a timer. We'll increase the score every second. So select the main node and create a new timer node. We're going to call it score timer. We leave the wait time to 1 second, and we don't want it to auto start. We'll start it when starting the game. Then we're going to enter main.gd, the script, and add a new score property, which will initialize to 0. This is where we start coding our new game and game over functions. We're going to start with the new game function, and every time we start a new game, the score, we want to reset it to 0. This will happen when the player clicks the start button. We also want at some point to start our timer. So we're going to get our score timer and start it. And in the game over function, we want to stop the timer. So function game over, we're going to get the score timer as well and call it stop method. Then we need to increment the score. To do so, we're going to use the score timer's timeout signal. So select the score timer node and double click its timeout signal to connect it to the main node. When the score timer times out every 1 second, we're going to add 1 to the score, and we're going to update the score in the heads up display. Remember, we created an update score function, and we're going to pass it the score number. Now we have to call our new game function somehow. Remember, we had a start game signal on the HUD triggered when the player clicks the start button. We want to connect this one to our main node to start the game, calling the new game function. We can directly connect the signal to the new game function. Select HUD, double click the start game signal, and we're going to set the receiver method here. We have to type the exact name, so new game. We click connect, and you'll see the icon appear next to the new game function. Now, when you play the game and you click the start button, the timer should start at the top. It's a bit messy because the monsters start spawning before that, and we're going to address this next. Now we have the score working. So select the mob timer, and in the inspector, we want to turn off auto start. Then we want to start it manually. We're going to delay everything, have a little sequence here. We're going to add a new timer node as a child of main and call this one start timer. We'll use it to delay the start a little bit and set its wait time, say, to 2 seconds. One thing we can do in new game here is we can get the start timer and start it before we start the score timer. So be sure you start the start timer first. And then we're going to introduce a new keyword in GDScript called yield. Yield allows us to wait for some node, some object, to emit a given signal. The code will read until the yield keyword, then it will pause the function until the signal gets emitted. This allows us to write sequences that take some time in a linear fashion, making our code readable. So we're going to get the start timer node here again, and we're going to wait for its timeout signal. So we start the timer, we wait for it to time out, and then we start the score timer. I almost forgot, we have to set the start timer to 1 shot. There we also want to start the mob timer manually. And I'll double check that I've turned it off, right? I turned the auto start off. Now we can play the game and click the start button, wait for 2 seconds, and then the monsters start spawning and the score starts going up. 2 seconds a bit long, so I'm going to select the start timer and lower it back down to 1 second. Anyway, this shows you how you can use the yield keyword to give a sequence some time. We're going to do a little more than that. So before our yield call, we're going to set the score back down to 0 in the HUD. I'm going to group that with the score up there. So we're going to get the HUD node and call update score with the current score, which is 0. This is so that when the player restarts the game, the score is set back down to 0. And when we start the timer, we also want to show a message. So we're going to get the HUD node and call it show message function. We're going to call it get ready, something like that. Then we'll wait for the start timer to time out and start the score and monsters. Let's try it out. I'm going to click start. It says get ready, and there you go. The message disappears when we start the game and we can start playing. Before we fix the size of the player and monsters, we want to call game over when the character dies. There again, we're going to select the player and connect its hit signal in the node tab. We're going to double click and connect it to game over on the main node. For now, we only stop the score timer. We also want to stop the mob timer, so we'll call mobtimer.stop. We're going to call hud.show game over, and we can now play the game to test this out. So we get ready. The monsters start spawning, the score appears. When we die, we get game over, and the score stays like this. Our function to show the game over doesn't reset the game yet, but we'll get to it next. Before that, I want to fix the huge size on the characters and the monsters because it makes the game really hard to play. The player is really too big, and so are the monsters really. To do that, we're going to open the player scene, and we want to set the size of the animated sprite and collision shape to something smaller. So I'll select the animated sprite, scale it to 0.5, 0.5. Have to go to the transform section to do so. Then for the collision shape 2D, we manually scale it down to the character's size. There you go. Now it's at a reasonable size. You could scale the player node directly, but it's something that's not recommended with physics. There are some cases where scaling a lot of nodes, including physics shapes like that, can cause some issues. At least it was the case in the past, so better size the other nodes properly. Then we're going to open the mob.tscn. For the monster, we're not going to reduce the size as much. So I'm going to set the scale of the sprite to 0.7, I guess. And for the collision shape, we resize it manually. We don't really have to worry about the visibility rectangle because all we care is that when the rectangle left the game window completely, the monster will be destroyed. Anyway, you can now press F5 to try the game again and see the monsters have a more reasonable size. We could increase the frequency at which they spawn or tweak other gameplay settings like their speed or something like that to control the difficulty now. Next, we have to complete the game over, allowing us to restart the game. Let's go back to the main scene and to the HUD to be exact. We're going to just open the script to complete the show game over function. So right now we just show a message, and when the message timer times out, the message label gets hidden. Here we're going to wait for the message timer to time out and display the game's title again. We can say yield. We're going to get the message timer and wait for its timeout signal. So as I explained, the function will pause here until the message timer emits the timeout signal, then the execution will continue. We're going to set the message label's text to our game title again. It's Dodge the Creeps. Then the message timer is going to hide the message label. So after it did that, we're going to make it visible again. We can call it show method to be consistent with the rest of our code. And finally, we're going to wait for a little bit of time and next show the start button again. So this will give us a nice sequence of events. And I want to show you another technique here. We can use the yield keyword. We can also create timers in code and wait for that timeout signal. To do so, you have to call getTree. This is going to get the object that represents your entire scene tree here. This tree has a function called createTimer, and you can create a timer of a given duration. So we're going to create a 1 second timer. These timers are one shot, they don't cycle. Then they have a timeout signal, which we can wait for using the yield keyword. So when you do that, it's like a throwaway timer. It will run for 1 second, emit the timeout signal, and then disappear. It's gone forever. But it's really convenient when you are coding something and you don't want to add new timers to your scene tree. And so when it times out, we show the button again, the button which will allow the player to restart the game. So let's test that. We click start. I need to die really quickly. Wait for the game over, dodge the creeps comes back, and we can start again. And if we click start, the monsters stay there, right? So we need to do a few more things to complete the game. We need to destroy all the monsters when we restart the game to start from a clean slate. We have to place the player again at the start, like to reset them, to show them again, to restart the gameplay. And perhaps when we start the game, we don't want to have the player behind the text. We want it hidden outside of the screen or something like that. So we'll do all that right now. First, destroying all the monsters. To do that, we go back to the main script, to the new game function, and around the top, we're going to use the group features we used on the monsters to delete them all. The access to group happens with the scene tree object we use to create the timer. So we have to call getTree to get that object, the scene tree, and it has a function called callGroup. It takes the name of a group. If I go back to the mob scene, remember we had a group named mobs in lowercase. So we're going to pass it the name of that group, mobs. Be careful to spell it right. And then we call a function on all nodes that are part of the group. We're going to call Q3. This will cause all monsters to be destroyed when the player restarts the game. We also want to call the start function we created on the player earlier. So we'll call player.start and want to pass it a given position. We're going to add a new node in the main scene, which will be the player's spawning point. So here's what we'll do. We select the player and move it outside the screen. Then we're going to add a new node as a child of main, and there's one called position2D, which gives you a little cross that's visual in the editor. We'll call this one start position and head back to the main script to get that start position. So we get the start position node and pass its position to the player. Why do we create a new node? Well, it's because during gameplay, the player is going to move. So then if you want to reset its position, you need a fixed thing, and that node gives us just that. Plus, it's nicely editable in the editor. Let's try the game now. We're going to call start, and we can move, we die, we wait for a bit for the button to appear. We call start, the monsters disappear, the character gets recentered. Have one last thing to do. You can see that at the start of the game, the player was visible. So we're going to open the script, and in ready, we're going to call the hide function. And that completes our main game loop. What do we have left? Music. We don't have any sound in the game, so we're going to add some music. You will find two sounds in the art directory. One is a music loop, and the other is a game over sound. So we're going to use both of these. To play music, you use nodes in Godot as well. So we'll select the main node and add a new audio stream player. It plays an audio file. We'll create that node and call this one music. We'll also need one for the game over sound because you can't assign multiple sounds to one of these nodes. So let's duplicate it with Control D, and we'll name this one Def sound. Okay, so select the music node. We're going to assign it the houseintheforest.ogg file. You place it in its stream property. And for the dev sound, you're going to click and drag game over the stream property. They both have a play function that we can call from code, so we'll do just that. Open the main script, and at the end of the new game function, we're going to play the music. We can do it before starting the start timer here. So we're going to get the music node and call its play function. Then we're going to go to game over, and on game over, we'll get the dev sound and play the dev sound. But we also want to stop the music. Otherwise, the two will play at the same time. So we get the music node and call its stop function. You can see the pattern where all the things you can play and pause in Godot have these play and stop method, whether it's for animation, timers, those kinds of things. Now I'm just going to open the audio tab at the bottom. This is where you can find the audio channels, and I'm going to mute it just for the recording and play the game, but you can play and everything should be fine. Now you should have the complete game with the music playing if you followed all the steps until there. So we have a game over, the game over sound plays, dodge the creep restarts, we can press start, the player goes back to the center, the score resets to 0. There you go. You made a complete game from scratch. It's a 2D one. And this has been an opportunity to see lots of things. You've done procedural generation, you've done some interface design, movement, testing collisions using different kinds of physics bodies. Congratulations, and thank you for following until here. There's a next video coming which will show you how to create a complete 3D game from scratch. People are often afraid of 3D, but you'll see that a lot of the code is very similar. If you like this tutorial, you will surely like our complete free email series. It's a complementary course to this one where I give more insights about game development, Godot, resources to check out. You can find the link on the screen in the description below. Be sure to also subscribe. And I'll see you next week when you'll do your first 3D game from scratch. See you then.